Okay, I consider number 3 to be a tough question. And they say they got a function over here. It's a rational function with some parameter c in it. And they're asking for me to determine what that c is, what the values of c that would make this have a range of all real numbers. And again, to me, it's a tough question. It's rational. And what I'm going to do is go to the whiteboard and basically just start looking at it and trying to come up with an answer. And the first thing I would probably do in this one over here is long divide, right? So let's write this down. And f of x is equal to x squared plus 2x plus c. And that's going to be x squared plus 4x plus 3c. And I'm going to long divide now, and I'll write this down for you. So x squared plus 4x plus 3c. And I'm going to put this down now, which is going to be x squared plus 2x plus c. And that would be, what times x squared would give you x squared? Just a 1, right? So it would be x squared. Well, division doesn't look that bad. 4x plus 3c. And then you would get, well, x squared disappears. You get minus 2x minus 2c. So this thing, if I did the long division, I would get 1 plus the unfinished business, which would be minus 2x minus 2c over x squared plus 4x plus 3c. Let me get my erase rate rid of the long division. I'm kind of done with that. And what I want to do is just look at this thing, and I start to realize that, there is, if I looked at the limit as the x goes to infinity, that there is an asymptote of 1. But they want all real numbers. They want this to cover everything. Right now I got it, in the limits going towards 1. Now what I'm going to do now is I'm going to rewrite the problem a little bit differently. I'm going to write it as 1 minus 2 times. And that's going to be what now? It's going to be x plus c over x squared plus 4x plus 3c. And this is the part where you can say, I don't know what to do with this, and it's perplexing, right? What I'm going to try to do is I'm going to try to work on this guy over here. And what I'm really trying to do for that guy over there, I want that guy to pump back all real numbers. Because in that case, I get 1 minus 2 times all real numbers. I get all real numbers. So I'm going to define a new function. I'm going to call it g. I'm going to say g of x is equal to x plus c. And then you're going to get x squared plus 4x plus 3c. And again, what I want is I want the range of this thing here to be minus infinity to infinity. And one way to do that is to look at the guy's inverse. And I want the domain of the inverse to be minus infinity to infinity. Now, by the way, it may not be strictly invertible. That doesn't really mean much to me at this point. So I'll write over here y equals, is how we find inverses, x plus c, and then you get x squared plus 4x plus 3c. To find the inverse, what you do, you reverse the roles between x and y. So I get x equals y plus c over y squared plus 4y plus 3c. What I need to do is try to solve for y now. And it looks like it's going to be quadratic, but I got to work on that. And you're going to get xy squared plus 4xy plus 3xc equals y plus c. And I really need to rewrite this guy so it looks more familiar to me. I'm going to say, x y squared, and then I see plus 4xy minus y. I'm trying to solve for 0, by the way. I'm just writing the terms down as I see them. And then, plus 3xc minus c equals 0. I'm going to say this is x times y squared. And then I'm going to say plus 4x minus 1 times y plus 3x, c minus c equals 0. Now, so this is why you're doing that. It's quadratic form, the reason I'm doing that. That's the a, the coefficient square term. This is the b, the coefficient. When I say that, the big A, the big B, and this would be the big C. So I'm ready to write down the quadratic formula, all right? So let's write that down. So what's y going to be equal to? Well, on bottom, it's going to be twice the coefficient of the square term, so it's going to be 2x. The opposite of the coefficient on a linear term, and then plus or minus. And by the way, what happens over here, that I want the domain of this guy over here to be this guy's range. That's what I want. All right? So my concern about this thing is, the domain of this problem over here. And I'm looking at this, and let me just write this down now. It's going to be the 4x minus 1 squared. Let's see, minus 4 times the a. That's the coefficient on the square term. And then that big C would be 3x c minus c. All right, doesn't look too good, does it? Let's keep working on it, though. By the way, domain might be an easier thing to handle, and I'm not sure about that. But I want the domain to be all the real numbers. And I'm going to multiply it out now, and I get 16x squared minus 8x plus 1 minus 4x squared. I'm not 4, I'm sorry, that's a mistake. Because it's 4 times 3, right? That's 12 x squared c, and then plus 4xc. Well, I need to neaten that up a little bit. And I get plus or minus. This would be 2x. And let's put this down now. Let's see if I can write that down maybe a cleaner way. I'm going to do the x squareds first, by the way. And I'm going to see, I have 16 minus 12c. And that's x squared. I just took care of these two here. So it's 16 minus 12c x squared. Let's go to the x's. It's quadratic in form, by the way, so I do this. And that's going to be, let's see, I'm going to be careful, too, because I know that things are all over the place. I'm going to say plus 4c minus 8x. I just took care of these two guys over here. I got the minus 8x and the 4c, and then I got a 1. Now, what I want is I want all the x's to come in. And a way to achieve that is to make sure that this thing here is going to be a positive number, right? I should say a non-negative number, all right? Because I don't want complex numbers. So I want to look at the discriminant now. And I want to make sure the discriminant of that, because I want that thing to be positive. I want all the numbers to come in, all the x's. But I want to assure that thing is positive. I can take the root of it. And let's write that down now. So I want that thing to be positive. So that means the discriminant would have to be negative. All right, think about it. There would be no x-intercepts for that. All right, but what I want, let me put this down again for you. I want this thing over here I want the domain of this guy over here to be all real numbers. So really what I'm worried about is the root of it. I want to make sure that all the numbers are allowed in, and the C's are really going to determine that. So really what I'm looking at is I'm looking at when this would be trouble. And when it's trouble is I want to say that discriminant of this thing over here. And again, I want this thing to, always be pumping back a number to me. So I'm looking at it, and I'm going to look at the discriminant now, right? It seems like an endless quadratic, doesn't it? So I'm going to put down the discriminant of this thing is going to be, that thing squared. Then minus 4 times this thing. Times the C, which is 1. The C is the constant, by the way. I know I say C a lot. It's really not C, it's a constant. And I want this thing to be negative. Or I should say less than or equal to 0. All right? In other words, no real x-intercepts. All right, let's see if we can do it. And let's write that down. So what's it going to be? Oh boy, this could turn out to be a nightmare, right? So you get 16 c squared. Let's see, 4 times 8 is minus 32, so minus 64c plus 64 minus 64. Let's see, plus 48c. All right, I think I'm getting close to what the c could be. Now I'm looking at this over here, and I notice something nice happened, but not everything. So 16c squared. These disappear. Minus 64 and 48 is minus 16c. I'm going to divide both sides by 16. I get c squared minus c. I'm going to factor the c out. Now let's get a little better. C minus 1 less than or equal to 0. What am I going to do now? Number line goes down. On the number line, I put 2 numbers where they come on 0. That's going to be at 1, and that's 0. Take some test values, like, 2, plug it in. You get positive, positive, which would be positive. That doesn't get shaded in. Oh, by the way, the 1 gets shaded because it gives you 0. This gives you 0. Between 0 and 1, I take a half, and you get a negative number there. That's certainly less than 0. If I go below 0, like minus 1, plug it in, I get negative times a negative, which is a positive, and that doesn't work. So right now, I've got an interval, and I'm not really quite clear about that, but the interval looks like it's between 0 and 1. All right, but I really have to, those endpoints really kind of bother me at this point, and I'm going to try to figure it out. And, what happens if c is 1, and what happens if c is 0? Let me go back to the original function. And the original function was, I'm going to look it up again, x squared plus 2x plus c, and the bottom would be x squared plus 4x plus 3c. I think we rewrote that, if you remember, 1. I don't remember, but I could always look it back up. It's up there, by the way. Yeah, I kind of remember doing that. Minus 2. X plus c over x squared plus 4x plus 3c. All right, let's try one at a time. Let's try the endpoint. But I can't try all the numbers. There's an infinite number of numbers. The endpoints are kind of bothering me. So I'm going to write f of x down. And I'm going to say c is equal to 0. Let's see what happens. What would you get? X squared plus 2x, x squared plus 4x. Well, I immediately detect a problem over here. And I want to tell you what the problem is. You're looking at, if you were just to factor it, you get x plus 2. And on bottom, what you get? You get x plus 4. Over here, what you get 1 minus, well, if I thought that, I'm sorry, if the c is 0, you would get 2x over x squared plus 4x. All right? Again, if you reduce that, I guess I could reduce that too, right? So it's 1 minus 2 over x plus 4. All right, a lot easier to look at. But, I'm looking at this over here. I got to think about the endpoints. That's an issue for me. So I'm going to say the domain of this over here, looking at the domain of that, it would be missing a number, right? What numbers it miss? Well, this would miss 2 numbers. So it would be all real numbers, right? But the numbers it would be missing is x equals 0. That's not allowed in. And the other number it's missing is x equals minus 4. So this is no good. All right, 2 numbers are missing from that. Let's put the next one down, f of x. And by the way, I have to exclude the 0 now, but let's look at the 1 now. So right now, c is from 0 forward. I don't know if 1's going to be included. So let's put down c equals 1. This is a tough question, by the way. What do you get? X squared plus 2x plus 1, x squared plus 4x plus 3. That equals 1 minus 2 times, well, it's going to be x plus 1 over x squared plus 4x plus 3. All right, let's take a look at that. And I'm looking at this one over here, and the top factor is to x plus 1 squared, and the bottom factor is to x plus 3, x plus 1. And what does that give you? Let's take a look at it. It gives you 1 minus 2. We get the same thing, don't I? What do you get over here? X plus 1. And then you get x plus 3, x plus 1. Well, I had another problem there. And what's missing from that guy? I'm going to say minus 1 is definitely missing, and minus 3 is missing. But here's the deal. I got to exclude that too. And what do we get? We get 0 to 1 now. So if you chose these c's over here, this f would cover all real numbers. All real numbers then. What do you mean the range of it would be all real numbers? The domain would also be all real. Thank you.